Hello, my name is Jacob, and I'll be teaching Python today for you guys. Yeah. Um, so real quick, the first lesson I kind of want to teach, or actually before that, can we go over the homework, the hidden word? Yeah. So if anyone finished it, that would be great. But I will show the problem, and we can go over it together. Okay. So let me share my screen. Yeah. Okay. Can everyone see my screen?
Yes.
Yeah. Okay. Okay. All right. The problem or the homework problem was called hidden word, and I'll just briefly explain or kind of just go over what this problem is saying. Right. So we are creating a guessing game in which a player tries to guess a hidden word. The hidden word contains only capital letters and has a length known to the player. Guess contains only capital letters and has the same length as the hidden word. After a guess is made, the player is given a hint that is based on a comparison between the hidden word and the guess, right? So basically, all we're doing is we're creating a word game, and the user has to guess what that word is. Okay. So the way this game works is that each position in the hint contains a character that corresponds to the letter in the same position in the guess. Right. So that basically means that when the user tries to guess a certain word, we will give hints to the user to show how close we are to that word. Okay. So the rules for that are as follows. As follows. So if the letter is in the right position, right? So that basically means if let's say like for this example, right? The A here, the second A is in the correct spot, right? Because our hidden word is harps. Harps has an A in the second character is an A, right? And since our guess has A in the second character, we will show the character right here as A. So that's if our letter is correct, right? If our guessed word has the correct letter, right? Then we will just print that character. But if that character is um, inside that uh, inside the hidden word, right? So let's pick a different example. Let's say S or not S. Let's pick R in this case, right? So R is in the word harps, right? It's the third character, but in our guess over here, heart, R is the fourth character of heart, right? So if the position of that character is wrong, then we will print the plus, right? And then the last case is the multiplication, the multiplication sign, the asterisk. And that's when our guess letter is not in the hidden word at all. Okay, so those are the rules. Any questions before I move on? Um, okay, if not, um, so I'll just quickly, briefly go over the example, right? So just in case, this is our hidden word, harps, right? And then we basically call the function get hint, right? Get hint is the function we're working on, right over here, if you can see, right? This is what we put in, and we're basically returning a string, and that's our hint, right? So this means that one of the letters is correct, right? It's in the second character, but everything else is inside the word, but it's not in the right position, right? So a string of 5 A's would return this because um, only the second A is in the right position. All the other A's are in the wrong position. and therefore we would print these pluses. Okay, so same for here, right? For a hello, this is a different case. So um, you see that the H is in the same position, right? It's the very first H, but all the other characters, right? These four characters are not in the word herbs. And therefore, we would display this asterisk sign. Okay. So those are the rules, and basically, kind of how to approach this problem is what I'm going to do is I'm going to use a for loop, and we're going to loop through each character of the guess, and we're going to check and compare. We're going to check and compare between the each character and each character of the guess and each character of the hidden word. Okay, so we're going to use a for loop, and we're going to iterate or loop through all the characters in our guessed word. So let's do that. I will pull up bullet and we'll start. Okay, so let me just quickly um, copy all this, right? Hidden word equals hearts. Okay, so our code here goes right over here. All right, let me just format this. It's a bit weird. Okay, so what I said as before, I want to loop through each character of the guess. So I'll do that for I and range, and then the length function, my word. Oops. Right. So what I'm doing basically is I'm looping through the indexes of the guess. Right. Since this is the length of my word, this is just saying I want to. Let me. Sorry. Okay. So I loop through each character of the guest. Okay. So I'll loop through each character, and what I'll do is I'll check a couple of things. Okay. So first of all, if the letter of the guessed word is equal to the correct letter, so in the case like here, right? If the first H in the guess is also the first H in the hidden word, then we will just print that character. Okay. Yeah. So also before I move on, I just want to mention this result. This is our empty string, and all we're doing in our code inside this loop is we're just going to append or attach each character one by one until we get our int. Okay, so what I'll do is I'll actually break up these rules, the three rules I mentioned before, into if, elif, and else statements. Okay, so the first case is if the character is in the right position and is the right character. So what we would do is we would do my word I is equal to hidden word I. Right, so this is just checking, very simple. If the character of the guess is equal to the hidden words character at that index, we will attach the character. So, yeah, right? If that's not true, then we'll check a different condition. We'll check if that character, right? This is the current character, by the way, the current character of the guess. If that current character is inside the hidden word but is not in the right position, we can check it like this. So there's a number of ways you can do this. Um, I prefer to use the in keyword if you guys have learned this. But there's also more methods you can use for this. But I'll just show you how to use the in keyword for now. Okay, so elif, and then we'll check if my word is in hidden word, right? And then we want to make sure to typecast this. right? Then we will attach it. We will attach. I believe it's a plus. Yep. Okay, a plus, right? And we'll say this. This is when the character is inside the hidden word, but it's not in the right position. Okay. All right. And then the last case, right? That's when the character is just not in the hidden word at all, right? And in that case, we will just attach um, this asterisk or this multiplication sign, and that basically means the current character does not exist. Okay, so I should work, and let me just get a couple of these. Yes, over here. And so okay. Okay. All right, so let's run our code and make sure. Okay, so we'll check this first case just to make sure it's right. So um, it's 5 A's, 1, 2, 3, 4, 5, and it will print that, right? And that makes sense, right? That's what we got over here, and it makes sense because, right? Again, the A is in the hidden word, but it's not in the right position, and that's true for all the A's except for this one, right? Okay, so let's move on to our next case. We have hello. Right? And in this case, right, this makes sense. H exists, right, is the very first character, but all the other characters in our guess are not in the hidden word. Okay, so let's move on to the other case, so heart. Right? This case, again, that's kind of self-explanatory. H is in the right position, but A and R are not in the right position, and E and T don't exist. Okay. Um, and that's true for harms, right? So in this case, um, H, A, R, and S are in the right position, but M is not in the right position, and it's not in the hidden word. So therefore, we just print that multiplication sign. And then lastly, we have our correct guess, and I'll print correct. Okay. Any questions about that? Feel free to, but oh, okay. Yeah. So, is there a way we could have questions? If anyone has questions. Oh, okay. Sorry. Um, sorry about that. So, I believe that. So I posted my code in. Oh, wait, let me edit that. Actually, I want to get rid of these comments just to make it nicer. Say, that's weird. Okay, I guess just the comments are weird. Okay, so that was my code in the live lecture notes channel. So feel free to look at it later on if you have any questions about it or you just want to see the code. Okay. Let me go back to share my screen. Okay, so that was our hidden word program. Um, if anyone does not have any questions about that, we'll move on to our next topic. Okay, so our next topic is about Python math, right? And so far we've been using in Python, we've been using a lot of operators, right? So plus, minus, times, divided by, even like your integer division, I believe modulus, right? So these are some of the operators in Python, but there's a lot more we can do in Python in terms of like math, right? So some functions that are built in to Python are the min and max functions, right? And so all these functions really do is they just check the greatest number between those arguments, and they will return it, right? So in this example right here, the one they give right here, we pass in 5, 10, and 25 to the min, or short for minimum, right? We pass it into the min function, and it will return the smallest value between those arguments. So 5, 10, 25. So 5 would be the smallest number returned. And then for the max function, which is short for maximum, we would print, or we would return, sorry, we would return the greatest number um, between these arguments. So that would be 25. And if we actually run this code, we'll see if it's 5 or 25. And what you can do is you can always just attach more numbers. You can always pass in more numbers into the min max function. So let's say we want to do, right, just keep on adding more, and it will still work, right? And if we want to change, let's say this max to include 100, 200, something like that, right? Our values would change. So, right, so 2 and 200, right? Because 2 is the smallest number in this group, and 200 is the largest number. So the min and max function, let's say instead of comparing these numbers, let's say we want to compare two numbers that are equal, right? What would happen if that uh, works out? So do 5 and 5, see what happens, right? Yeah, so nothing will really happen. It'll just pick one of the arguments because they're equal. Okay, so it doesn't really matter if you have equal arguments. It won't really affect anything. And I believe that's also true for the max function, right? Kind of simple. I think will happen. Okay, so that was the min and max function. Okay. Um, yeah. All right. Thank you. Okay. Um, moving on, we have the abs function, right? It's short for absolute. And in math, that's when you return the absolute value, or the positive value of the number passed. So in this example right here, the user or the code puts in negative 7.25. And when we pass it into the absolute function, we will get a positive value, right? So if we run that, that should give 7.25. And again, even if you don't put a negative, we'll still return the same thing. Yeah. So absolute value, you can just think of it as in math. If you've seen it before, it's those straight lines, and they basically return a positive value. Right. So that's the absolute function. It's kind of self-explanatory. I don't think I need to go over it too much. Yeah. Okay, so that's the absolute function right over here. And we want to, one more function we could go over is the power function, right? So it's pow. And you basically pass in two numbers, right? So the first number is your base. So it's the number you want to raise the power to. And then the next number is your exponent, right? What you want to raise it to. So right here they give the example of return the value of 4 to the power of 3. Right? So recall exponents, just in case you don't remember. Exponents are a neat way of shortening repeated multiplication. Right? So instead of saying 4 times 4 times 4, we can say 4 to the power of 3. And the way we do that in Python is we use this function right here. X equals pow, and then pass in 4 and 3, and it will return 4 to the power of 3. So run that, it should give 64. Yep. And we can do that for other numbers. We can say, well, let's try something a bit bigger. 5 to the power of, right, should give 125, I believe. Yeah, 125. I don't know, 5 to the power of 4. 625. Okay. So again, that's pretty self-explanatory. Believe I believe this is the same thing. This is oh, oops. Yeah. So oh yeah. So you can also use this right here. This is also built in. Yeah, I forgot to mention that. But you can use this or this. They are both the same. Um, yeah, forgot to mention that. Whoops. But so that's the power function, right? So far we've learned the minimum, maximum function, right? Just to recap, just returns the greatest and the smallest and greatest number. The absolute function that just returns the absolute value of the number, and the power function which just returns um, the exponent equation. Right? Okay, so that's most of the built-in math functions, right? So these require no like external packages or like importing, right? But let's say we want to use more functions, right? So because right now all we have are these three groups of functions. So Python has another built-in module called math. And this is basically for all of your other mathematical functions that you might need. And the first step in order to use this module is you want to type in into your code at the usually at the very top. We want to put import math. Right. So this is the import statement right here, and it is importing this module called math. Right. And once you import that, once you type in this, at the very top, you can start using that module, right? You can use methods and constants in that module. And it's a very great tool for, especially when you're dealing with math in Python, right? So the first example is the math dot square root function. Sorry, not function, math dot square root method, and it returns the square root of a number, right? So the square root of a number, in this case 64, would be 8. So if we run over this, yeah. So you can see again, the very first statement is the import function. Otherwise, if we actually delete this and run it, we'll get an error because math is not defined. Right, math is not defined, but right. So always make sure to import your modules correctly and put it at the top. Okay, and then this one is very self-explanatory. Math, right? We are using the module, and we are using the method inside that module called square root in this case, and we're passing in the number 64. And the square root of 64, in case you don't know, will be 8. Yeah, 8.0. But yeah, also, this will return a decimal value. And okay, turns. So that's the math dot square root function. Okay. All right. The next functions we want to go over are the ceiling and floor functions. So in math, they also appear not as frequently, but they appear sometimes. And if you don't know, just in case, the ceiling function is the ceiling and floor functions are rounding functions, right? And specifically, the ceiling function or the ceiling method rounds a number upwards to its nearest integer. So what that's saying is that it will always round up, right? And you can kind of remember it as ceiling, right? Ceiling is up, you think rounding up. And then on the flip side, we have the floor method. And the floor method always rounds down. So that's kind of similar to how the floor, you can always think of it as going down, right? So that's the math dot seal and math dot floor method. And let's see what, we'll just like play around with it a bit, right? So import math and math.seal. So let's do a couple of tests. So first of all, 1.7, we print that, and it will print 2. Yeah, 2. Okay, and that's just because the ceiling always rounds up. Let's try a different number. Let's try 1.1, right? So even though it looks like it'll round to a 1, right? Recall that the ceiling will always round up, and it will return 2. Okay? What happens if we do 1.0? All right, let's run it and see what happens. So in this case, it returned 1, and that's because this itself is an integer, right? So math.seal, again, it will only round up if it's bigger than the I guess you can say bigger than the previous integer. Okay, 1.2. So we'll leave it at that. And then likewise, the floor function, no matter the decimals, let's say like 1.9999, right? That will round down to 1. So yeah, and that's because the floor function always rounds down. So even if we put in like 1.3, we'll return 1. Likewise for, let's say, I don't know, 1.7, it will return 1. Okay, so that was the ceiling and floor function. Um, yeah, so the last kind of thing I want to go over is the pi constant. Right. So in math, you see pi a lot in like geometry and other math problems. So it's like it's the constant that equals 3.14 and then 1.5 and so on and so forth. And in math, sorry, not in math. In Python, you could import math and use the pi constant, right? So let's just see what happens, right? We import math, we set x equal to a constant, math dot pi, and we print that value, and we see we get the value of pi rounded to these many decimal places. Okay. Yeah. So I don't know if I can see if there's any questions. Yeah. Um, okay. If not, I'll just move on. But if there's a way I could see if you guys are need any questions, just let me know. Okay. Okay, so move on. Okay. Let me just delete all of these. Okay. So that's the math, kind of how we use math in Python. And if you want to, in your own time, you could go to this link right over here. And it will show basically all of the math methods and constants you could use beyond the ones that I mentioned. So if you recognize some of these, we have like arc cosine, uh, hyperbolic cosine. I don't even know what that is. Distance, right? You have all these stuff, GCD, right? um, radians, sine, math.u, right? You can look at this in your own time, and you can definitely like try out some of these methods and constants when you're doing math in Python. Okay, so that was just review of um, review of math in Python. Where's yeah, math in Python. So hopefully, all right. I'll move on to the next topic if you guys don't have any questions. If that's fine. So the next topic that I want to go over is scope. Right. So scope in Python, you can just think of it as a region in your code. Right. And what this means is you could you can only access a variable inside the region it is created in. So what do I mean by that? Um, so a local scope, right? First of all, is um, basically an area inside that function, right? Like in this case right here, the scope of the variable is set to this function inside this function right here. So what that means is that this variable right here, this x equals 300, can only be accessed inside this function. So let's try this out, right? So if we first of all try to access the x outside the function, right? This x right over here. And let's just like, I don't know, print x. We run the code. And yeah, right here it says name x is not defined. And the reason why is because x equals 300 is set in the scope of this function right here. So, and the reason why name x is not defined is because the code can't access, or the compiler can't access this variable right here, because x equals 300 is only available inside this function right here. So you can say that x has a scope, has a local scope within this function. Um, and okay, so if we can't access it outside, let's try doing some stuff inside the function. So let's just, I don't know, print, make a new variable s, and let's just say x times 2 something. And we'll try to print s. Right. Oh, can you enlarge your screen? Is it too? Is my screen still okay? Oh, oh yeah. Sorry about that. There. That's strange. Is it okay now? Yeah. Um. Okay. All right. Hopefully you guys can see that. Um. But anyways, like I was saying, um. Right. So the reason why this works. Oh, it still doesn't work. Oh, that's strange. Um. Oh, okay. Sorry. Oh, you mean that? Yeah. Sorry. Okay. Hopefully you guys can see that a bit better. Sorry about that. Um. So what I was saying is, I'll make it bigger so you guys can see. What I mean is that since we could access this x equals 300 inside the function, we can do a lot of stuff with it. But when we try to access it outside, yeah, okay, no problem. Um, when we try to access x outside, right, like this, we get an error, and that's because x is not defined outside the function, right? So x equals 300 is only defined inside this function right here. Okay. Oh, let's go over here. Oh, this is very big. Okay. So this. Okay. So like I mentioned before, the x is not available outside the function, but we could access this x equals 300 inside another function that's inside this function right here. So what I mean is that um, inside this function right here, this my func, um, x equals 300 is defined, right? And if we try to define another function inside that function and try to access x, that would work. And the reason why is because this function right here is defined inside this function right here. So, and since x equals 300 is set to the scope of that function, of this my func function, everything inside that will be able to access, right? But it is available for any function inside the function. Okay. So basically, as long as you um, don't try to access it outside this function, you'll always be able to access this variable inside this function right here. So I'll just show you what I mean, right? Um, so right here, what this function is basically doing is we're setting a variable equal to 300, and we're just printing this x right here inside this my inner func. And we run that code, right? We get 300. That works. Right? And then we can, I don't know, do more functions. So we'll have another um, def my inner function, and we'll try to access x again. Or run the code. Oh, we need to call this oops. Um, uh, we call my inner function. And that works because we printed this 300 first over here, and then we printed it again inside another inner function, right? So my point being that you can access this variable even inside nested functions, right? And that's all because the scope of this x is defined in this function right here. Okay. All right. That's nested functions. Yeah, so that's scope in nested functions. Let's say we don't want that, right? Because sometimes that's kind of inconvenient, right? If we go to our code right here, what if I want to access this x equals 300 outside that function? So that's also a very useful way you could kind of access variables within functions, right? Within local scopes. So the way we do that is we use this thing called a global scope, right? So the global scope is what it means is that the scope of the variable is set so that you can access it anywhere in the main body of the Python code. So, and the it's a very simple way. All you have to do is just define it outside of any function, just out here, right? And that way, your x equals 300 will be accessible anywhere. So inside this function, outside over here when we want to print x. Um, and yeah, so in this case, x equals 300 has a global scope. And that's because it's not inside any function, and it's just accessible anywhere. So we'll try this, right? We just run the code and it should print 300 two times, right? Once inside this function right here, because we could access it inside that function, and another time outside. Print x. Um, yeah. So another example. Let's say we want to find another variable. So n equals 5, right? So we'll do a couple things. We'll print. Let's print 5 times. Well, not 5. N times x. And here we'll print. Let's say I don't know. Print n plus x. And to print that should print 300 and then 1500, 300 and then 305. Right. So this is just another way that you could use global scope, right? And it's very useful because you can use it anywhere in the code. Okay, so that was global scope. Right. Right. So naming variables. So because of the local scope and global scope situation, if you have two variables with the same name and one has a local scope and the other has a global scope, we will have different values for x, right? So let's just open this code and see what happens. So if we print this, right, we will get 200 and 300. And the reason why is that outside here, this x equals 300 has a global scope and it's set to 300. Sorry. But inside this function right here, this my function, x equals 200. And when we print x inside this function, we are calling this variable right here, right? And that's because x is defined here first, right? So the way it worked is that when the compiler ran the code and you set x equal to 300 first, right? So this is your global variable. And then when it went inside this function right here, right? When you called this function and when it went inside, it changed the number, or it changed the number inside the function to 200. So changed value to 200. And then it printed x. But when we leave the function and we just try to print x again, we will get 300. And that's because right here, this right here is all, it all has a local scope. And so if we run that code, we will get 200 and we'll get 300, right? So just remember that if you ever have the case where you have two variables, one that has a global scope, one that has a local scope, and they have the same name, just watch out for this, okay? So this is kind of a little situation that could happen when you are dealing with functions and you're naming variables outside and inside the function. Okay. It should. Oh wow, it should go a bit quicker. Okay. All right. So, but what if you want to declare a global variable inside a function? Right. You can use this global keyword right here. And so this is the case where if you're stuck in the local scope, right? You can use the global keyword to get out of that. So right here, in this code, right? Global x equals 300, and in this case, x is our global variable, and it can be accessed to anywhere, both inside the function and outside the function. Right. So in here, it's accessed outside the function, and we run it. We'll print 300. Okay. Right here. Yeah. So in this case, like I mentioned before, if you're dealing with the same variable situation, if you want to just change this value right here, you would first define a global variable x, and you would set it equal to 200, and that way, when you try printing x again, now it will print 200 this time. Instead of, if you just get rid of this, right? it won't happen, right? It'll still equal 300. Right. And that's because again, this X has a global scope and this X has a local scope. So that's why if you want to change the the scope of X, right, you would do global X, right? The keyword and then the name of the variable. Yeah. So that's most of scope. Okay. Um if you don't have any questions, I'll try to move on a bit quickly. Uh, okay, so that's scope. Okay. Local, yeah, yeah, yeah. So the local variable has a higher priority than the global variable. Okay. So we learned math and scope. Let's move on to the next topic. Okay. And that's the Python try and accept. So just a quick review or a quick recap on what try accept does. Let's say you have a bunch of errors in your code, right? So if I give an example, let me actually make a new like, let me make a new bullet real quick. That'll take a while. So just while I wait for this to load, try and accept. Basically, what it does is you're testing a block of code for errors, and if an error occurs, then you will catch that exception with an accept block, and it lets you handle the error. Okay, so I'll just show you over here. Um, so we have a lot of errors in Python, and you might have seen that a lot, or sometimes when you're debugging your code. So some examples. Let's say this is a common error that might happen. Um, let's see. Let's try to divide by zero, because this is mathematically undefined. That's not a right number. If we print that, we'll get an error, right? Zero division error, division by zero. And so these are just some of the errors you might have seen before. There's also like you try printing a variable that doesn't exist, right? You should, yeah. So in this case, name x is not defined. This is a name error, right? So there's a lot more errors in Python, and the reason why we use try and accept blocks is so that we could handle the error. And the reason why that's useful is let me just show you over here, right? Let's say we try to print x. We didn't define x, right? Let's just try to print this x. Except if an error is catched or an error occurs, then we will okay. Can okay. Sorry. Um okay. And the reason why this is useful is we're basically testing if a code works, and if it doesn't, we will do another code. So this is kind of similar to you can kind of think of it as um, like an if else statement, right? If you try to run this code and it doesn't work, then else, yeah, you execute another piece of code, right? So this is very useful, and that way we don't because like if we don't handle the error, it will stop, right? Your code will stop and it will generate an error message, right? And we don't want that. If you see, right? We don't want these errors. Um, So that's why we want to try using try and accept, especially when we know that if an error might happen. Okay. Yeah, see? Without the try block, the program will crash and raise an error. And we don't want our program to crash. Right? So the way we use try and except, let me just show you right here. This is the basic format: try, and then colon, and then whatever code you want to execute. And in the case that an exception occurs, you do except colon, and then you put your code inside here. Okay, so that's try except. And yeah, so I'll explain this and this pretty soon. Yeah, so this is the basic structure of a try except um, block. Right. Let's say we have multiple exceptions, right? Um, so right now we have, yeah. Oh, okay. Yeah, so we have a lot of exceptions, and we want to, let's say we want to, for each exception or each type of exception, let's say we want to execute a special block of code, right? So in this case, right, you can attach multiple excepts, and you want to specify the name error, or like the name of the error. And what I mean by that is right here, this is the name of the error. So the name of the error for this case is name error. And that's because the name isn't defined. You saw zero division error before, right? So that's the name of an error. Um, and basically, what you want to do when you want to attach multiple except blocks is you want to put the name of the error inside right here. And that's when, um, and that will basically catch that type of error first. It'll execute some code. Otherwise, if it's a different type of error, it will execute this right here. Right, so this code is basically saying, um, right, you want to try printing x, except if you catch a name error, right? So except if name isn't defined, we will print this. And otherwise, except if any other error, we will print this. Okay. So we can kind of mess around with this, right? So right now it's set so that it will print this right here, and that's because x isn't defined. Let's do like a bunch of other errors. So like I just want to do zero division again, right? In this case, if we run the code, right, it prints something else went wrong. And that's because the type of this error right here is zero division error. And since it doesn't go to this except block, it will go by default to this, the last except block, and it will print something else went wrong. Okay. Um, we can also something else like, say we want to add a string. I believe this will also generate an error. We try to add what is it? An integer and a string. Yeah, so something else went wrong. This in this case, it's a different type of error. It's because we can't add a string and an integer together because they're different types. Okay, so that's try except. Um, we can also use the else keyword, right? So we've seen else before in our if else statements, and it's very similar. So what this means is you can use the else keyword to basically execute some code if no errors were raised. Right. So the else in this case is a bit different um, in that if your code doesn't generate any type of error, it will execute this code. Right. So um, this bit of code right here, all it's saying is that I want to try printing, or I want to try executing this bit of code. Except if I get an error, I will do this code. And else, if there are no other errors, I will execute this code. And right here, right, it says here, else block is executed. And that's because nothing is wrong with this code right here, right? Nothing inside this try block is wrong, or it doesn't raise an error. And that's why we, by default, go to the else statement. Right. So in this case, it finished the code, right? It finished printing hello, and then it jumped to the else statement, and it printed nothing went wrong. Yeah. So okay. Mm, all right. So we learned try, except, and else. So we can also use the finally block, right? And that will be executed regardless if the try block raises an error or not, right? So this is just this bit of code right here. If we try doing this, right? Even though an error was thrown right here, the print x, um, it still ran this code right here, and that's because the finally block. You can just think of it as always runs after try 7 is finished, right? Regardless, or even if the error is thrown, right, right over here, because the name error, right, it will still run this finally block, and that's just how finally block works. Okay, so that's the finally block. And yeah, so right here it says it can be useful to close objects and clean up resources. And yeah, so this is just, you can think of it as when everything is done, it will execute this code. Yeah, yeah. So anyway, do this. Yeah. Okay, so you probably might not know what this means, but you can think of it as we'll actually learn what this means later on. But right now, all it's doing is trying to open a file, and right here, this bit right here. So let me just go over here. Yeah. So this bit right over here is, you can think of it as saying, right, open file. You want to write to the file. Think of it as typing to the file, and except, right, except if you try to do this and it doesn't work. If you try to type to the file and it doesn't work, it'll print something went wrong writing to the file, right? And that's true because if something wrong occurs while trying to type to the file, then yeah, then an error would be thrown. It would print something went wrong when writing to the file. And then once we're done with everything, we will close the file. And this is just practice that I will explain a bit later on today. But yeah, so that's try and accept. We usually use this a lot with files because working with files is kind of tedious. It's kind of annoying to work with, and it's a great way to catch all these errors without crashing your program. Right? And then we'll print something wrong when opening the file. Okay, so that's just a quick preview of files. All right. Yeah. So in this case, it's saying, even if something happens or something's wrong with your file, the program will still continue, right? Because otherwise, if we don't have all these try and accept blocks, our program will crash, and that's not good. Okay. So, a thing you can do in Python is you can raise an exception. You can choose to throw an exception if a condition occurs, right? And how you do that is you raise you type in the word raise, and then you put in this statement right here, right? Exception, and then parentheses, um, anything or any message you want to show. All right, so let's try this and see what happens. All right. Yeah, let's do better. Okay, so right here it says trace back most recent call last, file line 4, raise exception, and the exception was raised, and that's because um x in our case did not meet this requirement right here, right? X was -1, and since it's less than 0, you raise this exception. So the reason why it's useful is you can create um, custom errors, right? And that could be useful sometimes if you want to show in your code, like if something wrong occurs. Maybe you want to like put a custom message, right? So in this case, sorry, no numbers below 0. And it's a great way you could specify like what type of error is happening. Yeah. So that's raising exceptions, right? You want to follow the same structure all the time. So it's the raise keyword, the exception with a capital E, and then parentheses around it, and you put your custom message inside the exception. Uh, so in this case right here, another example is this code right here is checking if the type isn't an integer, right? So if not type X is int. This is saying, so it will check the type of it, right? And if it's not an integer, it will raise this error, right? Type error, only integers are allowed. And you can see in this case right here, instead of using exception, we used a type error. And you can think of it as exception is your general what is it? Exception, like your general type of error. And if you want to be more specific, you could um, instead of writing exception, you can put type error. Right? So you can define, yeah. So you can define what kind of error to raise. Right, so right, if we go over here, it'll say type error, only integers are allowed. If we try doing this, right, exception, and we run it, right, it will say exception this time. Right, so this is just a good way to communicate what type of error is or what type of error occurred in your code that crashed your program. Okay. Um, yeah, let me know if I'm going too fast because we covered a lot already. Um, yeah. If not, I'll go quickly over um, our last and final topic, I believe, and is it- yeah, okay. We'll go over files. That'll be our last topic, and then I will go over some coding back problems for I believe it's Um, yeah, Logic 2. So if anyone tried doing Logic 2 and needs help with that, we can like try to go over it together. So yeah, that's for later. That's last. Um, okay. So our last topic for today, I think, yeah, if we have enough time, is Python files. So I think okay, Python. Yeah. So right here it says file handling is an important part of any web application. Right. So the reason why we use files instead of other data types is it can store a lot of stuff. Right. So far we've been learning like lists, like tuples, tuples, any other like type of like dictionaries. I don't know if you guys have learned dictionaries yet, but my point is that files are a great way for storing a lot of data in one location. Okay. So the basics of a file or how to handle a file is we use the open function. Right? So right here it says the key function for working with files in Python is the open function. So anytime you want an open function, right, this is the first step. When you want to use a file, you always want to put open or use the open function first. Right? And if we look over here, the open function takes in two parameters. That's the file name and the mode. Right? So let me kind of explain what each parameter is. The file name is the location of your file. Right? So put simply, it's you can think of it as like the address, right? So I don't know if VS Code works for you guys, but if I kind of show what I mean, um let me create a Python file. Oh, actually, and we'll call it files.py. Right. And let's try. So the way we define a file, first of all, is we do f equals open, and then we put in the name of the file, right? And then we put in the mode. So I'll explain what the mode is right now. But very briefly, I'll just show if we, let's say, make a text file, right? So the way you make a text file is say, well, example dot txt, and we put, I don't know, hello everyone. Right. What we do is inside this right here, the name of our um or the address or the location of our file right here, this text file right here, in this case would be the name of it. So example txt. Okay. So this bit right here just tells you where the file is, right? The file you want to open. Okay, so back to my little lesson. Oh, type. Oh, okay. Um, just this. Everyone can everyone open VS Code because we might need it a lot in the future. Yeah. So if any, can everyone open VS Code and see if it works right now? Yeah, that would be good. 'Cause, VS Code is very useful. It's a very powerful tool, and you can use it in place of like your online what is it, online Python like, compilers, right? Um yeah, so if you guys could let me know if VS Code works for you, that would be great. Um yeah, so if the teacher could let us know. VS Code is working? Okay, so it works for Eric. I hopefully it works for everyone else. But yeah. So like I was saying, I'll just show it again. Um so the first step in declaring our file object, right? Right here, this is our code for file for defining file object. Okay. F equals open that. So that's the first step. You want to put in name or sorry, not the name. Do you want to put in the location of the file? We go over here. Um, and the next part is the mode, right? So right here it says there are four different modes for opening a file. We have the read. So read is our default. So if you don't pass in anything right here, right? Instead of passing like another mode, like let's say X, right? And you don't pass in anything, by default, your file object will be um by default, it will have a read mode. Okay? So what the read mode means is it opens a file for reading. Right? It's kind of self-explanatory by its name. You're just reading the file. So you're trying to access the file. That's another way to put it. Akushi Cham. Oh, is it in VS Code? I could make it bigger, I think. Yeah. If you guys could see that. Sorry. Better. Okay. So hopefully you guys can see that. But yeah, so what I mean is that by default it has a read mode. It's file object. So you go over here. And okay, so the next mode is append, right? And what it does is it opens a file for appending, um, and it creates the file if it does not exist, right? So this part right here is kind of interesting, right? So if our file doesn't exist, it's not defined anywhere, then it will automatically create a file and it will open the file for appending. So you can think of it as it attaches data to a file, and if that file doesn't exist, then it'll just create it. Okay? Because like right here in our read mode, right, it throws an error if the file does not exist. Okay, so the next mode is the write mode. And what it does is it opens a file for writing. It's kind of similar to the append mode, but it creates the file if it does not exist, and it erases any previous value. So in a bit, I'll like give a demonstration on what each mode does. But right now, all you need to know is that it opens a file for writing, and it creates the file if it does not exist. So very similar to append, but I'll show you later the difference. Okay. And then the last mode is create, right? And then we use this letter X, and it just creates the specified file. That's all it does, and it returns an error if the file exists. Okay, so that's our four modes. Okay. And in addition, you can specify if the file should be handled as binary or text mode, right? So, as we know, files they could take in different values, right? So the type of values we're working with right now are text, but we could use binary later on. But we usually use text. It's just easier to see, right? Right here it says images, so the images are binary files. So yeah, but by default, your file object will be in the text mode. Okay, so right here, to open a file for reading, it is enough to specify the name of the file. Right, f equals open demo file.txt, right? And right here, right, you can see this code right here. This is equivalent to this code. And the reason why is because R is our default value and T is our default value. Right, so if you recall, R is the read mode and T is for text. So I'll actually open VS Code and kind of demonstrate what each actually, this is, yeah, so I'll demonstrate what each part does. So let's just quickly create a text file. So you can follow along if VS Code works for you guys. Let's create a demo file.txt file. Now let's create a text file and we'll basically copy all this text. Okay, so let me get rid of this. Wait. And the way you define a file or the way you add a new file is you can click either this button right here, the plus and the fold, right? And it will create a file. And then you always want to make sure to put the name of the file. So in this case, we want our file to be demo file. And then this right here is your extension, right? This tells you what type of file it is. And we want it to be a txt or text file. So let's do that real quick. Demo file.txt. Right, and our demo file.txt is created. See right here, we have, this is our script or our code, our Python code, and this is just our text file. Right, we'll copy paste all this from here, right? And now we have a text file that contains all of this text. Okay, so we go over here. Let's tidy up this code. And like it says over here, we want to open the file and we want to read it. Right? So for reading, and basically what it does is this open function, it returns a file object. So this is just a neat way of saying you're creating this file and you're just reading it. Okay, so let's try that out. Um, So we'll do it exactly like how they do it. I'll do this. All right, copy, paste. Okay, so f equals open demo file.txt, and then R mode right here is R. But remember, by default, it is not is by default it is set to read mode, so you don't really have to put that right here. But I'll just put it just so I can do it exactly like that example. Okay, so right here we're just creating our file. I'm going to read it. So the way you run code in VS Code, you can either do here. You can start debugging and then, or you can just run without debugging. So I'll just run without debugging and we'll see what happens. Right. So right here. Yep. So it worked. Yeah. So what it did is it opened the file, set to read mode, and it read the information and printed all of the file out. Okay. Let's go right here. Okay. If a file is located in a different location, you'll have to specify the file path. So that's what I said earlier. And a great example you can do in VS Code is your folders, right? So let's create a new folder, and you can do it by this icon right here, clicking right over here next to the VS Code. You click that, and let's make a folder. So to folder, and let's try moving this text inside that folder. Move, right? And now our text file is inside this folder right here. Instead of it being outside, right, right over here, it's inside this folder. So let's see what happens. Let's try running this again and see what happens if we do that. Run without debugging. And right here, it generates an error. File not found error. No such file or directory. And that's because the directory, or basically you can think of this word as the location of our file, it changed. It changed from it being this demo file.txt to a folder. That. So what this is saying is inside this folder right here, this text file exists. And you separate each, you can think of it as a stage, right? Because you're basically inside this folder. Yeah, so you're going inside that folder, and that's a stage. You're being more specific with the location, right? So the folder by itself is just this folder right here. But if you want to specify what's inside that folder, you put a backslash, and you put the name of the file. So we can actually do this with even more files. Sorry, not files, more folders. So let's say we want to oh, it's not the same. Out of date. Can you run Python? Oh, that's a problem. Uh, okay, just try to follow along. Um, yeah, just watch my screen and try my best to explain it. Yeah, VS Code doesn't work. Okay, so like I was saying, right? We want to change the location of our file because our file moved to a different location. Right. So if you can see I don't know if you can see it, but if I hover over this text file, it shows me the location of that file inside my computer. So I wonder if I could just copy the path just to show you what happened. Right. So this is like this demo file.txt is the location inside my computer, inside my machine, and in each step it's going down and down and down and down, right? Um, all the way to this file right here. And so the reason why we use these slashes is we want to separate the file type. So it's initially it's a folder, and then we want to be more specific, right? So we put the name of the text file. Yeah, so I can run on Google Colab if you want. Um, yeah, let me actually do that. That'll be much easier to follow along. Let's see. Um, okay, so this is another way you could. This is like a website where you could run code, right? So you can do like print hello, right? And you press this right here. If you guys haven't used Google Colab, right? It's a very simple online editor. And let's do the same thing with files. So the way you add files is you can right click over here, right in this empty space in the new file, and we'll do the same name. So demo file.txt. And let's do our same bit of code. So the way you add more lines to go inside this editor is you click right over here. Oh yeah, yeah. So I'll wait a bit. So just take your time to if you're following along, take your time to open this website, and we can all uh work on it together. Yeah, yeah. So the teacher provided the link in the Discord in the question and answer channel. So you guys could go to that website and follow along. So if I actually go to that website, let me show you. Question and answer. Yeah, you click this, and it will look something like this, right? And all you do is you press new notebook, right? You press new notebook, and you will create a fresh new file, right? So just take your time. Maybe give like 2 minutes just in case. Um, yeah. So you could like name it whatever you want. Um, yeah. Okay. I hope that's enough time. Okay. So let me actually show you how to make the file one more time because you might have not caught that. But what you want to do is right here, here. So it will look like this initially. You'll click right over here, the table of contents, right? And then you want to click files. Right. So there's a little section just for files, and the way you add a new file is you right click right over here, this empty space. You just right click and then new file, right? And then you could name it. So in our case, we'll do demo file.txt. Okay. Um, let's make some new code and let's make our file object. So f equals open, right, is demo file dot txt, and read by default. So that should be fine. And we want to print to the user, right? Everything inside our file. Sorry. So if we run this code, oh wait, we don't have anything in the file. Whoops. Yeah. So let's go to our file. Um, and let's try to copy all this. Okay. Right. Should be good. All right. Now let's run this code. Yay. Okay, it worked. So it printed everything in the file. So pretty neat. That's for reading. Okay, so I'll go pretty quickly. Read. Yeah. So we explained this earlier. If you put your if you put your text file in a different folder, then you would have to change this bit right here. And you want to modify it by putting like before we had to do something like this, right? Because it was inside a folder named folder. Yeah. Okay. Thank you. Thank you. Okay. All right. So that's for right here. This f dot read. This this returns everything inside that file, right? But let's say we want to access like certain parts of the file. So right here in this case, let's say we want to uh, access this line right over here, or not this line. Let's say we just want to access this word hello, right? So it says by default the read method returns the whole text. But you can also specify how many characters you want to reject, right? So by default, if you don't put in any number inside the read method, and you put in, let's say, 5, right? This 5 right here means return the first 5 characters of the file. Okay. So if we actually try that in our Colab or Google Colab, let's change this to 5. And feel free to mess around with the values, right? You can do like, I don't know, 20 and see what happens. Let's see, yeah, let's actually see what happens if we do 20, right? Right here it says, hello, welcome to, that's because it um counted up to the 20th character. Yeah, it's over here. Okay. Um, I'll just do the example. The example said 5, right? You run this code, and we get hello. Right? So that's pretty useful if you want to access by character. You want to access a specific number of characters. Okay, so that's for if you want to get characters of a file. But let's say you just want the whole line, right? So this whole line right here, or this whole line right here, or this whole line right here, you would use a different method. You would use dot read line. Okay, so let's use that method and see what happens. Right, dot read line. Yeah. Also, the great thing about Colab is it helps you with. Right here, see, it says what type of parameter to put in. It like spells checks for you. It's a very useful tool. Yeah, so definitely recommend. Yeah, so let's do f dot read line, and let's see what happens. So for that, it says hello, welcome to demo file dot txt, and right here it read one line of the file. So by default, this red line only reads one line at a time. So if you want to read multiple lines, so let's say you want to read these 2 lines, you would have to call another print statement and then read line. Okay, so we get this. Yeah. So hello, welcome to demo file txt. This file's for testing purposes. But you can see right here. Whoa, why is there a gap? Why is there a gap in between that? And that's because it might you might not be able to see that there's actually a new line character um at the end of each line. So what it's saying is the reason the way we declared the file, right, is line by line so we finished the first line and then we pressed enter, right? Right? The moment we press enter, we have a new line character over here, right? And that's just a neat way for the computer to keep track of new lines, right? And if we look over here, the Python print statement by default, uh, it prints with a new line. And that way, each line is a different, or each bit of code is in a different line, right? So the way we could fix that is we can do this end equals that, I believe, that will, oops, yeah. So if we run this, oh, whoops, I need to, yeah, so right here, to run that, oh, oh, whoops, yeah, make sure to put parentheses. There you go. See, now there is no space in between each line. And that's because we use this right here. This is just a way of saying don't end with a new line character. So it's just a neat way. Um, okay. I have to go quickly. All right. So you could so we've learned reading characters, reading lines. We can also loop through. We can use for loops for looping through the lines of the file. So you can read the whole file line by line. So right here, this code right here, this is just saying for each line in F, we want to print it out. Okay, so I'll just do that really quick, and I'll show you what happens. Right, kind of simple, right? Right here, and it will print every file. Yeah, so the same problem occurs again because there's a new line character in each line. But yeah, um, so that's that. All right. So lastly, this is very important. It is good practice to always close the file when you are done with it. So every time you're done using the file, you want to close it, right? And this is very useful. Right here it says you should always close your files. In some cases, due to buffering, changes made to a file may not show until you close the file. Right? So you want to close the file so no other changes occur. Right here. Yeah. So you do that by f.close. Okay. Um, all right. Next mode. Okay. So, if you recall, I was talking about the write method and the append method, and we'll show the difference between the two. Okay. So right here it says the append will append to the end of the file. So it will attach data to a file. But our write, it will overwrite any existing content. What it means is it will delete any content in that file and replace it with something else. Right. So let me give an example. So right here, um, we will, okay, so it says here f equals open that a, and we will append content. Okay, let's do that in our collab. Let's see what happens. So right here, I will copy all this code. Um, yeah, right here. Oh, this, okay. Recall that if the file doesn't exist, right, this file, and it doesn't exist, right, you don't see demo file 2.txt, we will uh, it will create the file by default. So um let's try what happens. Yeah. So if we oh wait, that's strange. Didn't work. Demo file the txt dot files. Oh, that's weird. That's strange. Hmm. Yeah, it should create the file. That's weird. Okay, I'll just create the file and show you. So we'll create a new file. Oh, never mind, it showed up. That's weird. Okay, let's close this. Let's open this right here. Wait, yes. Okay, so right here, if we open this, yeah, now the file has more content. And what it did was it opened the file, set it to append, and it attached this data. Right. So if we want to attach more, let's say we want to attach another line. So hello, future of Tanzania. Right. We run this code, and now um it should. Oh, yeah, yeah. So it attached. Oh, that's not good. It's new line. Yeah. So it attached hello future of Tanzania and this because we ran it 2 times. Right. Um, and the append mode. Just you just want to make sure to know that append mode does not have new lines. So what that means is that right here you can see it kind of gets weird. It will just attach it to the line, right? Okay, yeah, yeah. And it will keep on attaching it to one line. So you can fix that by using a new line character. But yeah, so that's the append. So right here it says open and read the file. Okay. So this is just a way of opening it and you are going to print everything in that file, right? So that's what this code is doing. So that's the append, right? Let's see what happens if we write to this. So we will copy this code and we will uh, yeah, paste we and run it. You see, you have all this content right here, right? Um, and that's cool, but let's try using the write mode on this file and see what happens, right? So I'll change this bit of code. Here, I'll just attach it here. F equals, actually, first we want to close it, right? We're done using the, oh, let's close it first, and then we're going to reopen it. So F equals open. We will, for demonstration, let's see what happens if we do this, right? And we write hello. Oh, I spelled hello. Hello, right? And then now we try. Let's try printing f.read. Or yeah, so let's try printing the file, and then let's close it. Okay. So just remember, this is what it looks like before. This demo file too. Now the file has more content. Now the file has more content. Hello feature to the. Okay, so that's what it looks like before. But what happens if we run the write method? Or what happens if we change the mode from uh, read to write? So if we run this code, oh, whoops. Oh, I thought, sorry. I thought, wait, this, yeah, sorry about that. I thought right. Yeah, so we would have to do that again. Oops. So, yeah, so this method, um, this right here, this you can only call if you are in the read mode, right? So the reason why I threw an error was because I was in the write mode right now. And you always want to make sure to change the mode when you are either writing right here or you're reading. So let me do that real quick. F equals open demo file 2.txt and read. Okay, so now it should work. Oh, so now we open demo file, right? You can see it changed, right? It got rid of everything and replaced it with that. So that's what I mean by overwrite, right? You're deleting all the content before in the file and you're replacing it with a different different set of values. So right here, we had all of this stuff and then we just replaced it with hello. So that's how you can remember it. Write overwrites, right? Deletes everything before places. Yeah. So the write mode overwrites and it deletes everything before and replaces it with new data. And then on the other hand, right, the uh, the append mode right here, it just attaches. Yeah. So append will attach, write will overwrite. Yeah. So yeah. And then lastly, um, the last the last file mode we want to use is X, right? So X means create, right? And if you look over here, right, to create a new file, use the open method with one of the following parameters. And you can see right over here, um, not just for the create mode, but for append and write, if the file doesn't exist, it will create it, right? So you can use that to your advantage to create a file that doesn't exist. But this right here, it will create a file and it returns an error if the file exists. So try that again. Oops. Let me make a new bit of code. Okay. So f equals open, and we just want to create a new file. So let's do uh, .txt, and we will set it to x, right? X for create. X for create. Let me just make this a bit bigger so you guys can see. Okay, so f equals open FOT and x. Um, let's print. Oh, not print. Okay, so let's do that. So we run this bit of code right here, and it should just create that file. So it worked. This takes a long time, but yeah, I don't know why. Okay, there you go. See, this the fot.txt file was created. Right, so this is just very simple. It just creates the file. Okay. Um, I believe that's all. Oh, delete files. Okay. Yeah. So I'll go over this very quickly. Um, if you want to delete a file, right? So far we've been overriding it. That was the closest to deleting it. But if we want to delete the file permanently, we would have to use the OS module, right? So kind of similar to the math module, right? You want to import the module and then run os.remove. So let's do that very quickly. Oh, we have no time. Right, so import os, and right here it says os.remove and then the name of the file. So os.remove. Let's say we want to remove demo file 2 right here. Demo file 2.txt. Right. Oh, and then make sure to put it in uh, quotations, right? It's a string. This is always a string. And let's run this bit of code right here. You can see takes some time to refresh. There you go. Our txt file is gone. Right. So that's how you delete files. And right over here, this is just saying if you want to avoid getting an error, you want to check if the path exists. Right. So we can do that too. Um, yeah. So let's see if os dot path dot exists, and we put in the file name. So let's put demo file txt. And if you do that, you want to remove it. Else, right? You want to print the file doesn't exist. Yeah, okay. Print file does not exist. Okay, so let's run this, right? So just to kind of go over what this means, right? We're seeing if demo file exists, if that location exists, and it does right now. Okay. And what we will do is if it exists, we'll remove it from the system. So let's run that code. It worked. Let's refresh and see what happens. Yep, our demo file text is deleted. And let's try to run this again, see what happens. Right? File does not exist. And that makes sense because we removed it, right? And we can't remove a file that's already removed. So this right here, the os.path.exists, it returned false. So I moved to the else statement and it printed this right here. So file does not exist. Right. Yeah, yeah, okay. Okay. And lastly, if you want to delete an entire folder, so we haven't been using folders. Actually, let me create a folder. Folder. Okay. And if you just want to delete a folder, you can just do this, right? So os.rmdir, um, and you put in the name of the folder. So right here, let's say I don't like this folder right here. Let's delete it. os.rmdir, and then we'll put the name of the folder. So that's folder, and run the code. And if you refresh, folder's gone. Okay, so that's I was deleting files and folders. Okay, do we have time to go over logic 2? Don't know if we have. Right. Feel free to ask any questions. Before we end, anything about right math, scope, try except, um, delete, or not delete. Sorry, files. Let's wrap up. Okay. Please stop sharing. Okay. Yeah, I think. Sorry, I I didn't. I think I went a bit too slow. But yeah, I think we will end right. And yeah, so feel free to ask any questions about the coding bat problems before we end. Um, if not, should I just yeah, okay. So yeah, so class is over today. Thank you for listening. And hopefully I will see you on Monday. All right. Thank you. Bye.